Hi my dear students, welcome to my channel. Today we are going to discuss regarding to the concept of trigonometry. In the last class we were discussed up to introduction and at the same time naming and the different trigonometric ratios we were heard. If anyone is not gone through these three parts, so I already posted the video part 1 of trigonometry. So see that and come to here. Okay, today I am going to discuss regarding to the trigonometric ratios for specific angles and at the same time complementary trigonometric ratios and at the same time identities. These three parts we will discuss in this class. Okay, so first I will tell you trick how to remember. Then I will tell you if there is a question will be asked based upon to derive the angle. So that is also you should able to do in exam. So that basis also I will discuss later. Anyway, I will tell you trick first. So you have a hand, your hand having a 5 angles as like this. So turn as like this. So how will be our hand? This is smaller line. This is the next finger. This is a forefinger. Okay, this is a next this as like this. Okay, is it clear? So this is our hand having a 5 fingers. This is small finger, this is next, okay, middle finger, forefinger and as well as a thumb. So in this small finger represents like 0 degrees, okay, next 30 degrees, okay, next 45 degrees, next 60 degrees and 90 degrees. So we are discussing trigonometric ratios for specific angles. Specific angles. What those specific angles? For that I drawn this diagram for you. So what is the trick is simply under square root, okay, number of fingers left by 2. Okay, so if I will close the first this finger, then only one finger left. Is it clear? Next, if I will close this finger, 2 fingers are left. If I will close this is 60 degrees, then 3 fingers are left. If I will close the thumb, then there is a 4 fingers are left in my hand. Okay, so by 2 we have to do it. This is what the logic to remember. Okay, my dear students, I hope you understood what I am saying. We have 5 fingers. First, remember their angles in the anti-clockwise direction. 0, 30, 45, 60, 90. If I will open this finger, what is this? This is 45, middle finger. Okay, if I will open this is a 60. If I will open this is 30. This I will open thumb, then it is called as the 90 degrees. Then, if I will say that the logic here, I am writing quantities for the sine theta. Okay, sine 0 degrees, sine 30 degrees, sine 45 degrees. Okay, then sine 60 degrees, then sine 90 degrees. So first, if you remember the one value easily, then another you will get automatically. So sine 0, there is no fingers are left. So under square root of 0 fingers by 2, simply called as a 0. Means sine 0 is 0. Okay, sine 0 what? 0. Next, I could say here sine 30 value if you want, then sine 30 if you want, then what we have to do is close your second finger from the this is, then only one finger is left. Sine 30, only this is I closed. This is a one finger is left. Okay, then sine root 1 by 2. Root 1 is 1 by 2. Next, if I close the middle finger, it is root 2 by, it is 2. Root 2 in this root 2, sorry, here the bottom 2 can be written as root 2 into root 2, because root 2 into root 2, root 2 whole square, anyway 2 only. So this one is cancelled once, so 1 by root 2 is left. Simply if I close this as the middle finger, number of fingers left is 2, that is value we are getting 1 by root 2. So simply sin 60 is easy. Why? 3 fingers are left, so directly root 3 by 2, there is no calculation for that. Sin 90 is this finger, so total lesson I will discuss based on this only, please concentrate here. So sin 90 is 4 fingers are left, so root 4 by 2, root 4 is a 2, perfect square it is, by 2, 2 2s gets cancelled 1, so it is a 1. So my dear students, if you are not understood, please recall the video again and you can listen it. Okay, done. So this is how we will, this is a sin 30, sorry, sin 0 is 0, sin 45 if you want, 1 by root 2, sin 60, it is nothing but root 3 by 2, so sin 30, 1 by 2, sin 90 is 1. So on your fingers 5 values are there, please recollect. Okay, so if any finger if I will fold, you have to say, now say the value, sin 45, 1 by root 2, sin 60, root 3 by 2, sin 90, this is 1, the small finger is a 0, let us say this is queen, queen is 0, king is a 1. Okay, the middle one is a 1 by root 2, this is a root 3 by 2, this is a 1 by 2. So if you know the numbers on your fingers, then others cos will becomes easy to you, cos will become easy, cos. So cos 0, so now here onward 0 we were took for sin, reverse you take for the cos. Cos 0 is a, this is 1 we thought, no, directly write value now. Cos 30, this is root 3 by 2, no, root 3 by 2. This is a sin 45, cos 45, both are same, that means 1 by root 2. Here cos 60, what is the value on this finger is there? 1 by 2. This is a 0, no, this finger, this is a cos 90 is a 0. I hope you understood, right? Okay, next tan, how to remember? Tan is very simple. You have to remember 3 values are most important here. What they are is, see 0 by anything is 0 only, 1 by 0 infinity. So tan 0 0, tan 90 is infinite. So 1, if you remember tan 30, that is 1 by root 3, if you will divide these two, 2 gets cancelled in denominator, 1 by root 3 is left. Upper value is a tan 45, denominator value is a tan 60. Okay, so if you remember tan 30, numerator is a 1, that is tan 45, denominator is a tan 60 root 3. So this is how logic we have to remember. So rest of table, if you know this is, you reverse those at the time of your usage, you can get it. Okay, my dear students, so as for the my best knowledge I given to you, okay, if not once again recollect it is, you can get easily. So now you see that the trigonometric ratios how we were analyzed. So very simple logic it is, but concept also very important. So how to calculate trigonometric ratio for the 45 degrees. So trigonometric ratio for 45 degrees. Let us take a isosceles right angle triangle. So this is a right angle triangle, but two sides are equal. Let us say this is A and this is also A. So how to calculate hypotenuse? I told you hypotenuse square is nothing but, hypotenuse is nothing but side square plus side 2 square, whatever may be there. So here it is a A square plus another side also A square, that is a root 2 A square, that can be written as root 2 into root A square. This and this gets cancelled, root 2 into A. So hypotenuse is nothing but simply called as root 2A. So you can take anything here, namings are like this. So I will take angle at the A. So it is a right angle as they were said. Then other two angles sum also should be right angle. Then if two sides are equal, then their opposite angles also equal. So those two angles sum should be 90 by 2 45. This is 45, this is also 45. Now sin 45 I am writing anywhere, either at A or at C. Sin 45 means what? Opposite by hypotenuse. A by root 2A. So this is gets cancelled. So 1 by root 2. Okay, my dear student. Previously we have seen logic. Now we have seen the how to calculate. Okay. Next, cos 45 you want. Cos 45 you want. Cos 45 is adjacent. This is the opposite we got took. This is adjacent. This is called a hypotenuse. So it is A by root 2A. A gets cancelled. Then again we got 1 by root 2. So it means sin 45 and as well as cos 45 are same. Now see the tan 45. Tan 45 is simply we got one right over there. Here opposite by adjacent, that is A by A, which is equals to 1. So tan 45 is a 1. If you want remaining trigonometry ratios, cosec theta is equal to 1 by sin theta, then we can call as a 1 by root 2, 1 by root 2. Okay, 1 by root 2. One denominator with the 1 by root 2. So simply it is called as a root 2 by 1. It is a root 2. Sec 45. So it is 45 degrees. It is also 45 degrees. That is 1 by cos. Okay, theta. That is 45. So it is also root 2 by 1. Okay, next cot theta if you want. Cot 45. From this is reverse of tan 1 by 1 is becomes a 1. So tan 45, cot 45, 1. Sin 45, cos 45, 1 by root 2. Secant 45, cosecant 45, root 2's. Okay, my dear students, up to here you should be clear. Next, we will go to the another trigonometric ratio angle, that is nothing but the 30 and 60 degrees. We will do it. Okay, so let us take a equilateral triangle with 2A as a side. So T ratio for 30 degrees and 60 degrees. So 30 degrees and 60 degrees, I am taking sides as a 2A. It is an equilateral triangle. So each side is become 60. So each side is nothing but 60 degrees. Now what I want to construct, this is a ABC triangle. So I want to draw a perpendicular to the BC. So it will become third side. So here let us take this is nothing but D. Then here we will go with the side as a, this is A. The third side we have to calculate. Third side if you will calculate, then we will make it as under square root of 2A square minus 2A whole square minus A square. So which is equal to, we can call it as 4A square minus A square. It is equal to 3A square minus, 4A square onwards 1A square is gone, 3A square. Then we can write root 3 into A square. So root 3 into A. So height is became root 3A. Okay. So we extract the triangle now outside. See, from the isosceles triangle, equilateral triangle, we were calculated height so that it became the as like this. It is root 3 into A. This is A and this is became 2A. As we were drawn the perpendicular bisector here, it became 30 degrees. Angle also became half 30 degrees, and this is became 60 degrees. Now what we can able to do from this is means write the trigonometric ratios for the 30 degrees and as well as 60 degrees. So sine 30 is equals to sine 30 degrees. So this is 30 degrees. I will change the color pen so that you can able to understand easily. So it will become opposite for 30 degrees. Okay, for this angle this is opposite. This will become adjacent. For 60 degrees we will draw one more triangle. This will become hypotenuse. So for 30 degrees opposite is become A by hypotenuse is became 2A. A and A gets cancelled. Then what is left? 1 by 2. I to shown same thing now by folding this finger 1 by 2 we have got it. Similarly cos 30 if you will see cos 30 adjacent is nothing but what? Adjacent is root 3 into A by 2A. It is get cancelled under square root of 3 by 2. See, I to shown the same thing. It is a cos 30 from this side root 3 fingers by 2. Okay, next tan 30 if you will see tan 30 opposite A by adjacent is root 3 A. A gets cancelled. So 1 by root 3. So I told to remember this is to get the remaining values. So 1 by root 3 is a tan 30. If you reciprocal this, then you will get rest. What is that? Cosec 30 degrees is 2 by 1 is 2. Sec 30 degrees root 3 by 2, reverse it. 2 by root 3 we will get it. Next cot 30, if you will reverse it is root 3 by 1 is root 3. Okay. Next we will draw for the angle 60 degrees. We will write it now. So we will extract it, the angle triangle. What we were extracted? This is nothing but 60 degrees. This is became root 3 A. So this is became A, and this is equivalent triangle side is 2A. So from this is what we can write the rest of trigonometric ratios. See, so sine, this is angle, right? Now this will become opposite. This is adjacent. Okay, this is hypotenuse. So sine 60 degrees is equals to, previously I told you root 3 by this finger I folded, 3 fingers are there, root 3 by 2 I told. Opposite how much here? Root 3 into A by hypotenuse is 2A gets cancelled. What is the answer, ma? Root 3 by A. Okay, so next cos 60. So this finger I folded, I know I told you 1 by 2. See, this is adjacent is A by hypotenuse 2A gets cancelled off, that is 1 by 2. Next, if you see for the tan 60. Tan 60 amount I told there is a trick I told you, root 3 it is. So opposite by adjacent, that is root 3A by A gets cancelled, simply called root 3. If you make a reciprocal of these three, you will get rest of angles. That is what? Simply cosec 60 is sorry, here it is 2. So 2 by root 3. Next sec 60, which is 2 by 1 is 2. Next cot 60, 1, that is root 3 is become 1 by root 3. Okay, so this is about the angles which are formed with the triangles 30 degrees and as well as 60 degrees. So still we have to see proof for the 0 degrees and as well as 90 degrees. So angle 0 degrees, how it is formed? So 0 degree means the hypotenuse should be lie on the adjacent side. So how it is? So if you see, this is a base. Okay, so I could draw the height of the triangle with the help of this is. So this is what the height is. Okay, then third side hypotenuse I will draw as like this. Now slowly the angle which is formed at A is a theta if I will imagine, I will decrease the angle so that height is become reduced. So if I will decrease the angle, then what happens? This height is get reduced to this is. Still if I will decrease, why I am making a 0 this is. So if I will still decrease, then height is becomes decreased. Still this will become height. So still if I will decrease the height so that it is becoming this is height. So as height is becomes a 0 for this triangle, then the AC which is equal to AB will become, that is hypotenuse will become the adjacent. So if hypotenuse and adjacent are same, then sin theta can be written as the opposite by hypotenuse. But what about here height? Height is opposite. Opposite how much? 0. 0 by anything, that is hypotenuse. Okay, is become 0. Next, cos theta. Sorry, that is theta is here what? Cos is theta is 0 degrees we are taking, right? This is 0 degrees. Okay, so here adjacent by hypotenuse. Adjacent how much? It is equal to hypotenuse. So hypotenuse by hypotenuse both are cancelled and it become 1. So cos 0 is became 1 as like this. Next, tan theta if you will take tan 0 degrees, that is opposite by adjacent. So opposite is 0 by adjacent, it is become 0. Okay, I hope you understood. If not, recall the concept which is inbuilt in the triangle. Okay, next cosec. Cosec 0 degrees. Okay, cosec 0 is 1 by 0 is becomes infinity, not defined. Okay, sec it is 0, it is become 1 by 1 is become 1. Next tan 0 reciprocal, sorry, cot 0 it is, not tan 0, cot 0 it is 1 by tan 0, so it is becomes the infinity. Okay, in this way for 0 degrees. What about the right angle? Right angle if you will see, that is for 90 degrees. Angle for the 90 degrees if you see, so basically there is a triangle will be as like this. Okay, this is angle, this is some acute angle here, this is adjacent, this will become what? Opposite. This is hypotenuse. So slowly if I will increase this is angle to right angle, then what happened? This is a base. So if I will increase the angle, okay, then this is becoming a decreasing. Which one? Actually this is A, this is B, this is C. So this is A, this is become B, this is C. It is moving to B dash as angle is getting increased. Still if I will increase, see that the triangle is get formed as like this, C dash this. Still if I will increase, still there is a B double dash is, means this side is getting decreased. So now adjacent is become 0 if I will do this is, and here there is the side which is formed, okay, which is nothing but that we will call as the hypotenuse. This hypotenuse is becoming equal to the opposite side. Okay, hypotenuse is becoming equal to opposite, adjacent is becoming 0. So hypotenuse is became opposite, both are equal as there is angle is increasing to 90 degrees. Then what I can say is sin 90 is equals to opposite by hypotenuse. But opposite is equal to hypotenuse now. So hypotenuse by hypotenuse is becomes 1. Similarly, cos 90 degrees if you will take, that is adjacent by hypotenuse. But adjacent is became 0 by hypotenuse becomes 0 by anything is 0. One more tan 90 degrees, tan opposite by adjacent is became 0. So opposite by 0 is become not defined. Rest of angle you can write yourself, like sin 90 become cosec 90 also becomes 1. Okay, and secant 90 is becomes 1 by 0 is not defined, and we can say cot 90 is anything by infinity is becomes 0. So in this way, okay, we can able to derive the trigonometric ratios with the help of triangles. I hope you understood in the particular concept which we were done. So this is completed. What is the trigonometric ratios for some specific angles are completed. Now from that is you make your own table which is given as like from your textbook from the whole concept. Okay, this if they will ask to derive, then you can derive as like that. Next, here we go with the complementary trigonometric ratios. Let me draw the triangle for you. So if I will draw a triangle, so this triangle we are getting as like, this is like some triangle we are getting, but we want a special case of right angle triangle, so we draw ourselves. So right angle triangle I am drawing. So right angle triangle if you will draw as like this. Look at here carefully. So this is a right angle triangle. In this, what are the angles are possible for us? We know clearly. This is A, this is B, and this is a C. So this is a 90 degrees, very clear to us. So either angle is possible here, then angle at A plus angle at C together should be equal to 90, because sum of the interior angles of triangle is 180. Then one angle 90, other two angles sum should be 90. If A is theta, then C is becomes how much? It is becomes 90 degrees. C is becomes 90 minus theta. So other angle which is possible in the same triangle is 90 minus theta. So sum of the two angles is became 90. Then A and C are called as a complementary angles. Okay, some students will get confusion with the supplementary and complementary. In ABCD, C first will come, so remember as a 90. S will come later, so remember as a 180. Okay, this trick also will help you. Now, if you see, there is a complementary trigonometric ratios. How we will write from this triangle? So complementary T ratios for A and as well as C we have to write. That is what the thing, right? For angle A I am writing. So sin A, that is sin theta, is equals to, what is that? If A is become here, opposite is becomes, that is BC, adjacent is becomes AB. Anyway, hypotenuse does not changes. Hypotenuse becomes common, that is AC. Okay, little bit check it. Okay, so now write how much you remembered yourself, you can come to know from here now. So sin theta means opposite, that is this side is C. So BC upon it is AC. Cos theta is simply, we can say, adjacent upon that is AB upon AC. And moreover, tan theta we can write as, that is BC upon AB, that is opposite by adjacent. Now make a reciprocal. Cosec theta is inverse of sine, that is AC upon BC. Next, cosec after sec theta is equals to, that is AC after AB. Okay, next, tan theta can be written as, it is reciprocal, sorry, cot theta can be written as reciprocal of tan. Cot theta is reciprocal of tan, that is AB upon, it is AB upon BC. So this is for the 90 degrees, sorry, it is a theta. Next we will see complementary trigonometric ratios. In this angle is becomes at C. Angle C, what is that? 90 minus theta. So opposite side for the 90 minus theta is AB. Opposite side is AB. Okay, and we can say adjacent is becomes that is BC. Hypotenuse anyway same. So write that sin theta is 90 minus theta is becomes sin 90 minus theta is becomes opposite AB upon hypotenuse is AC. Similarly, cos 90 minus theta you can say as adjacent BC upon AC. Tan 90 minus theta, simply it is nothing but the AB upon AC. Cot 90 minus theta, I am writing here. What we will get? Cot 90 minus theta reciprocal of tan. So it is BC, sorry. AC not BC. So BC upon AB. Still, what is it? Cosec 90 minus theta is the reciprocal of sine, that is AC upon the AC upon the AB. Next one more, secant you write it, that is reciprocal of cos AC upon BC. Sir, why did you written this? I want to make a correlation between these. What is the relationship between the given trigonometric ratios for the theta and 90 minus theta? So look at here carefully. Here RHS of sin theta is BC by AC, and RHS of cos 90 minus theta is BC by AC. It means RHS are equal, LHS are also equal, that is cos 90 minus theta is equal to sin theta. So the complement of sine is cos 90 minus theta, or complement of cos 90 minus theta is nothing but sin theta. Observe the cos theta here. Cos AB by AC, you see that here sin 90 minus theta, AB by AC. So sin 90 minus theta is became cos theta. Now write the conclusion down. What we got it? Sin 90 minus theta is became cos theta. Cos 90 minus theta is became, it is sin theta. Okay, this is what our conclusion we got it. Next, we will go to the one more thing. So tan theta, you see that BC by AB. Okay, you see here cot 90 minus theta BC by AB. It means cot 90 minus theta is tan theta, and you see cot theta, see that AB by BC, tan 90 minus theta AB by BC. So it is tan 90 minus theta is the complement of tan. So write the conclusion here. One more conclusion, what we got? The one more conclusion we got it. Tan 90 minus theta is became cot theta. Then cot 90 minus theta is became tan theta. Okay. My dear students, observe, concentrate on the class. Okay, very important thing is it is. Next, Cosec, you see that AC by BC. There is AC by BC is there, sec 90 minus theta. So secant 90 minus theta is a complement to cosec theta. Cosec, see, A last one. This is AB by AC by AB, AC by AB. So these two are complement. Is it clear? So there is a one more complement trigonometry ratio, that is secant cosecant 90 minus theta is became a secant theta. Secant 90 minus theta is became a cosecant theta. Okay. These are the complement trigonometric ratios. Okay, my dear students, what the conclusion we can able to draw from this is, that is nothing but, so sine is becomes a cos. Okay, sine theta is became what? Cos. Cos is became sine. Tan is became a cot for complement. Cot is became tan. Next, secant became a cosecant. Cosecant became secant. So this is what the conclusion from our topic. Okay, I hope you enjoyed this concept. Let us go to the last concept in this is, that is trigonometric identities. So this is also very important concept. So trigonometric identities. So trigonometric identities. So trigonometric identities, if you see clearly how they were gets formed. So let us take a right angle triangle. So from this right angle triangle, A, B, C, right angle at B. Okay, so write the Pythagoras theorem from this is, what we can write, hypotenuse that is square is equal to sum of the squares of other two sides. Like I will say, AB square plus BC square is equal to AC square. Let us take this equation 1. So case 1, what the case 1 is says, divide AC square on both sides with AC square on both sides. That will become AB square by AC square plus BC square by AC square, which is equal to AC square by AC square. AC square by AC square will become 1. This can be written as AB by AC whole square. This will become BC by AC whole square, which is equals to 1. Okay. So if you observe, AB by AC from the triangle, what we know? If the triangle is formed at A, then this will become opposite. This is a adjacent. This is called hypotenuse. So the AP is BC is called opposite by hypotenuse. This is AB by hypotenuse is called cos. So cos square theta plus it will become sin square theta is equals to 1. So this is what the first identity we have. Okay, first identity is related to cos square theta plus sin square theta is equals to 1. Second identity, case 2, same triangle. This is an angle, this is A, this is B, and this is a C. Now divide the equation 1 with the AB. Okay, if you divide with the AB, what happens? So equation 1 divide with, so with the AB square. Then AB square if you divide, what is equation 1? It is AB square plus BC square is equals to AC square. So dividing on both sides with AB, so AB square by AB square by AB square. So AB square by AB square is became 1. So it can be written as, plus, what we can write, BC by AB whole square plus AC, so is equals to, AC by, it is AB whole square is became. So AC is opposite, by AB it's adjacent, so it became tan. Square there, no? So tan square theta plus 1 is equal to AC is hypotenuse by AB is adjacent, so it is nothing but secant square theta. So tan square theta 1 plus tan square theta is equal to, it is 1 plus tan square theta is equal to secant square theta. Then we can say secant square theta minus tan square theta is, means transfer this side, it will become 1. Okay, this is what the second trigonometric ratio. Third one, case 3. What is the equation 1 ma? AB square plus BC square is equal to AC square. So divide with the BC square. Okay, divide equation 1 with BC square. What we are getting, AB square by BC square plus BC square by BC square is equal to AC square by, it is BC square. Let me draw the triangle in rough. A, B, C, and this is theta, opposite, adjacent, hypotenuse. So anyway, this is became 1 plus 1 adjacent, sir, this can be written as AB by BC whole square is becomes AC by BC whole square. So AB is adjacent by BC is opposite, so it becomes the cot theta square plus 1 is equal to AC by BC, it is a cosec, COSEC square theta. So cot square theta plus 1 is equal to cosec square theta. If you transfer this side, then it becomes a cosecant square, SOSC square minus cot square theta is equals to 1. So these are the 3 trigonometric identities we have. Okay, let us recall simply what are the first trigonometric ratio? Sin square theta plus cos square theta is equals to 1. Second one, what? It is simply secant square theta minus tan square theta is equals to 1. Third one, cosec square theta minus, it is a cot square theta is equals to 1. Okay now. So how to remember? Everybody can remember easily. What is that? Sin square plus cos square theta is equal to 1. So next one, what? These are continuous numbers, S and T. So S after T will come. So ST secant square minus tan square is equals to 1. Okay, anyway you will subtract also, you will get 1 basically in their number logic. So next, if you see third one, cosec square theta minus cot square theta, COSEC bigger onwards, cot small. If you subtract 1, in that way you can remember this identities. Okay, my dear students, with this we were completed the whole concept of trigonometry. Have a great day. Thank you. Okay, please, if you not understand, watch again and copy the notes. Thank you.